What is structural glazing? Structural glazing is a high-performance bonding solution for glass in modern architecture, where glass panels serve as a significant part of the building's structure. In this system, glass is bonded to the building's frame using strong adhesives, creating a continuous, unobstructed glass surface. This eliminates the need for conventional framing, allowing for more aesthetically pleasing designs with clean lines and improved visibility. Brief history and evolution. The journey of structural glazing began in the mid-20th century, driven by architects' desire to push the boundaries of design with glass in exterior facades. The advent of robust yet flexible sealants and adhesives during the 1960s and 1970s marked a pivotal moment, paving the way for glass to become a key structural element. Through years of material and engineering advancements, structural glazing has evolved, leading to the creation of energy-efficient, high-performance buildings that captivate with their glass-centric aesthetics. Components of structural glazing. Types of glass used. In structural glazing, the glass is not just a decorative element, but a critical structural component. Therefore, the types of glass used are specially engineered for strength, durability, and safety. Commonly used varieties include tempered glass, heat-treated to be much stronger than standard glass. Laminated glass consists of two or more glass layers bonded together with an interlayer, providing enhanced safety and acoustic insulation. Insulated glass units, IGUs, comprise two or more glass panes separated a space to reduce heat transfer. Sealants and adhesives. Sealants and adhesives play a crucial role in structural glazing by attaching the glass panels to the framework of buildings. These materials need to endure different types of stress, while ensuring that the seals are both airtight and watertight. Silicone-based sealants are often preferred for their strong, flexible, and weather-resistant properties, along with their effectiveness in bonding to both glass and metal surfaces. Supporting frame materials. In structural glazing systems, glass serves as the main element bearing the load, but is usually mounted on a lightweight frame. This frame can be made from various materials, including aluminum, which is favored due to its excellent strength-to-weight ratio, resistance to corrosion, and the simplicity of working with it. Steel, chosen for its robustness, particularly suitable for larger structures or those bearing significant weight. Composite materials, which are gaining popularity for their unique features, including lighter weight and enhanced thermal efficiency. To sum up, structural glazing represents an advanced building method that combines high-tech materials and engineering to blend visual appeal with structural integrity. Key elements like glass, sealants, and support frames play crucial roles, each adding to the system's overall strength and longevity. Types of structural glazing systems. Stick systems. Stick systems, a classic approach to structural glazing, involve individually mounting glass units to a building's framework. On-site assembly of the framing elements, or sticks, precedes their attachment to the building's exterior, followed by the glass panels installation. This technique offers considerable design flexibility, accommodating diverse architectural forms. Yet it demands more on-site labor and extends the installation duration, rendering it less efficient than alternative methods. Unitized systems. Unitized structural glazing systems are fabricated in a factory, assembling the glass, frame, and other elements into large panels ready for installation. These pre-assembled units are transported to the site and attached to the building's framework, frequently using cranes. This approach drastically cuts down on installation time and on-site labor, providing a quicker, more streamlined assembly. Such systems are particularly suited for tall buildings where reducing on-site construction duration and labor is essential. Point-fixed and Spider Systems Point Fixed, and Spider Systems embody a contemporary, minimalist, structural glazing style, utilizing minimal hardware, such as stainless steel fittings or spitters to secure the glass panels, giving them a floating appearance. These systems typically anchor the glass at corners or edges with point-fixed supports, enhancing transparency and light entry. They are preferred in architectural designs, aiming to maximize natural light and achieve visually impressive glass facades with minimal obstruction. Advantages of structural glazing. Aesthetic appeal. Structural glazing gives buildings a smooth, contemporary look, significantly improving their architectural appeal. It allows for the creation of seamless glass fronts, giving architects the flexibility to craft bold and creative designs. The continuous glass surfaces afford broad vistas and foster a deep link between the inside and the outside, lending a sense of openness and harmony with the environment to the structures. Durability and performance. Structural glazing systems are built to resist environmental pressures like wind, temperature fluctuations, and earthquakes. They employ strong glass and sturdy sealants, providing a facade that is both durable and enduring. Furthermore, these systems are crafted to adjust to the movements of buildings, minimizing the likelihood of glass shattering or structural collapse over time. Energy efficiency and insulation. Contemporary structural glazing systems frequently include insulated glass units, IGUs, and low emissivity, low-E coatings, enhancing their thermal performance notably. These components play a crucial role in decreasing heat loss in colder seasons and curtailing heat gain when it's warmer, thus reducing the energy needed for heating and cooling. Such energy efficiency lowers operational expenses and aids in bolstering the sustainability credentials of a building. Safety and security features. In structural glazing designs, the priority is on safety and security. The use of laminated and tempered glass, known for its strength, ensures that even in the event of breakage, the glass stays intact thanks to the bonding interlayer, mitigating the risk of injury and preventing unauthorized entry. Moreover, the latest glazing technologies may incorporate features like impact resistance and bulletproofing, enhancing the security level and providing extra reassurance. To sum up, structural glazing systems present a harmonious mix of aesthetic appeal, functionality, and performance benefits, establishing them as a favored option in modern architectural endeavors. Their capacity to merge visual attractiveness with utility has spurred their widespread use in the construction of commercial, residential, and public edifices across the globe. Disadvantages of structural glazing. Cost considerations. The main drawback of structural glazing lies in its steep upfront expenses. The use of premium materials like high-performance glass and specialized sealants drives up the cost compared to traditional glazing systems. The intricacy of its engineering and design demands specialized knowledge, adding to the total expenditure. Furthermore, the need for precise manufacturing and installation processes increases the financial outlay, marking structural glazing as a considerable investment. Installation complexity. Installing structural glazing systems requires meticulous precision to maintain the facade's integrity and performance. It involves skilled workers and detailed coordination, especially in unitized or point-fixed glazing systems, where there's little room for error. This complexity often results in extended installation periods and the necessity for special equipment, elevating project expenses and logistical hurdles. Maintenance and repair challenges. Structural glazing, known for its durability, can present challenges in maintenance and repair. Cleaning or replacing glass panels that are high up or integrated into the structure often demands specialized tools or scaffolding. When sealants give way or panels are damaged, fixing these issues becomes a complex and costly affair, especially if the design of the system does not support easy removal or repair of individual panels. Unique applications of structural glazing commercial buildings. Structural glazing is a popular choice in the commercial industry for crafting striking, see-through facades that boost the visual allure and exposure of office spaces, retail environments, and exhibition areas. These glass features lend a contemporary, vibrant look, drawing in customers and clients, and they capitalize on natural lighting while providing clear views of the external environment. High-rise and skyscrapers. Structural glazing is often favored for high-rise buildings and skyscrapers because it offers sleek, uninterrupted glass facades that enhance the building's iconic look. Glass's lightness and strength enable creative designs that make a statement in city skylines. Additionally, incorporating structural glazing in tall structures reduces the load on the building's framework, as glass is comparatively lighter than conventional construction materials. Residential applications. Luxury homes and upscale apartments are now frequently adopting structural glazing to install large windows, glass walls, and sliding doors. This trend aims to provide panoramic views and a smooth flow between indoor and outdoor spaces. The use of structural glazing not only elevates the visual appeal of the living area, but also improves its functionality, creating an open and spacious atmosphere that allows for abundant natural light and expansive views. Custom and innovative uses. Structural glazing opens up possibilities for creativity and innovation in construction, not just limited to the exteriors of buildings. It's used in creating glass walkways, bridges, atriums, and even glass ceilings, bringing a distinctive, light-enriched atmosphere to spaces. These uses highlight the flexibility of structural glazing, allowing architects and designers to venture beyond traditional architectural norms. To sum up, despite the challenges related to expense, installation, and upkeep, structural glazing stands out for its diverse applications across different types of buildings, underlining its adaptability and the unique contribution it makes to contemporary architecture and building practices. Installation process of structural glazing design and engineering facade. The process of installing structural glazing starts with an intensive design and engineering phase, where architects, engineers, and glazing experts work together to develop precise plans and specifications for the glass panels and their supporting framework. They decide on the best type and thickness of glass, frame design, and the appropriate sealants and adhesives to use. They also perform structural analyses to check that the glazing system can handle environmental pressures like wind, snow, and earthquakes. This stage is vital for spotting potential issues and guaranteeing the system's safety, efficiency, and visual attractiveness. Fabrication and assembly. After finalizing the design, the production and assembly of the structural glazing components occur typically in a controlled factory setting. This environment guarantees accuracy in crafting the glass panels and frames and permits pre-assembly of parts, particularly for unitized systems. The glass undergoes cutting, tempering, or laminating and is coated as needed before being fitted into the frames. Quality assurance is critical at this stage to ensure that each component meets the established standards and is prepared for installation. Site installation and sealing. The last phase of setting up is physically installing and sealing the structural glazing system on site. In stick systems, the framework is built on the building's exterior, followed by the placement of glass panels. Unitized systems, on the other hand, come pre-assembled to the site and are directly fastened to the building's structure, typically with the aid of cranes. The sealing phase includes the use of high-performance sealants to create airtight and watertight connections between the glass panels and the building's framework, ensuring the structure's durability and protection against the elements. Maintenance and care for structural glazing. Cleaning and inspection routines. To keep structural glazing systems both looking good and functioning well, it's crucial to clean and inspect them regularly. Use the right methods and materials for cleaning to prevent harm to the glass and sealants. Inspection should focus on detecting any issues with the sealants, glass, or structure. It's advisable to carry out these checks at least once a year, or more often in severe weather conditions, to guarantee the system's durability and safety. Repair and replacement strategies. When dealing with structural glazing systems, it's crucial to have effective repair and replacement methods in place for any damage or failure. Small damages or issues with the sealant might be fixable right there and then, without needing to take out the glass panels. But for bigger problems, it might be necessary to replace the whole glass unit. Being prepared with extra panels and the right sealants can help keep downtime and disruptions to a minimum. Also, it's important to work with skilled glazing experts who can properly evaluate and fix the system's issues, ensuring it continues to perform safely and efficiently over time. To sum up, managing structural glazing systems well means having a solid plan, being precise, and regularly checking on things to keep them running smoothly. This careful approach is key to extending the life and effectiveness of the glazing system, which in turn plays a significant role in the building's overall strength and functionality. Future trends in structural glazing. Technological advancements. Structural glazing is on the brink of major technological breakthroughs, focusing on improving performance, longevity, and design versatility. Innovations like smart glass, particularly electrochromic glass, offer the ability to regulate light and heat flow through windows, which boosts energy efficiency and comfort while preserving natural lighting. Furthermore, the creation of tougher, more durable glass and enhanced sealing compounds is set to support bigger and more intricate glazing designs, expanding the possibilities in architecture. Sustainability and green building trends. The construction industry now prioritizes sustainability, shaping the development of structural glazing. Upcoming trends involve embedding photovoltaic cells in glazing units for renewable energy generation, aiding the building's energy needs. Glazing systems with enhanced thermal insulation and lower energy use will become commonplace, reflecting the worldwide shift to energy-saving, eco-conscious buildings. Additionally, recycling materials in glass production and adopting environmentally friendly manufacturing methods will be emphasized to reduce the ecological footprint of glazing systems. Market growth and demand. The structural glazing market is poised for significant growth, fueled by a rising demand for cutting-edge, energy-saving building solutions. The trend toward urbanization and the preference for contemporary, visually striking buildings are key drivers, especially in the commercial and luxury residential segments. With economic expansion and escalating infrastructure investments, emerging markets are anticipated to increasingly adopt structural glazing systems, thereby broadening the market on a global scale. Conclusion. Summary of key points. Structural glazing marks a pivotal advancement in the realm of architectural design, blending beauty, practicality, and eco-friendliness. This approach enables the creation of vast, uninterrupted glass exteriors that redefine contemporary architecture, fostering new design possibilities, and enhancing the efficiency of buildings. Examining the essential elements of structural glazing, including how it's put into place and looked after, as well as its distinctive uses, underscores the system's adaptability and significance in the building sector. The significance of structural glazing in modern architecture. Structural glazing is a key player in modern architecture, epitomizing the forward march of innovation in the design and construction of buildings. It stands out not just for its aesthetic appeal, but for its role in promoting sustainability, improving energy efficiency, and creating better spaces for people. Looking ahead, structural glazing remains a vibrant area, with new developments continually influencing urban landscapes and our views on architecture. In essence, structural glazing is crucial in contemporary architecture, marrying beauty and strength with a commitment to eco-friendly practices. Its ongoing evolution ensures it remains at the cutting edge of architectural progress, responding to the evolving needs of both the industry and society.